Good morning, guys. I'm going to make a video presentation today. This is in relation to my previous vessels or a continuation about remaining cargo to load. Okay, let's start, guys. Now, with this program, with this problem, this is example 4.5. And it says a vessel is to complete loading on a wind drop of 9.55. Meaning, guys, she's loading in the port, and his target drop is 9.55 meters. He's floating in a density of 1.025. So we assume she's floating in one density 1.025 because it doesn't say here. Now, she is presently floating to a drop of 32 or 9.32 meters, meaning at present he is floating and a drop of 9.32. So with this drop, according to the loading plan, when she reaches this drop, the what you call uh what you call this one the foreman at board has already stopped loading and advised the chief officer to take draft around the vessel to compute on how much remaining cargo to load. So since the let's say the draft surveyor is already on board, so the chief officer and the draft surveyor is now taking or will take a draft survey around the vessel of forward and up and mean port to starboard around the vessel. So once they have completed the reading of the draft, then they're going to compute how much remaining cargo to load. Okay. Now in the initial drop of 9.32, the TPC is 35.29 metric tons. And the question is how much more cargo to load. So the final drop or the sailing draft is 9.55 meters and the present drop is 9.32. So if to get the sinkage, the final drop minus your present drop is your sinkage, which is 23.23 meters or 23 centimeters. Then the formula of to get the cargo to load or remaining cargo to load is sinkage times TPC times 100. So sinkage, which is 23 centimeters times your TPC, which is this one, 35.29 times 100, which is a constant, and your remaining cargo to load will be 111.7 metric tons or 812. So this will be the remaining cargo to load. Okay, so we use the program. This is one. So your initial drop is 9.32. 9.32. This forward. I'm sorry. Good. 9. Oh, I'm sorry. 9.32. And up is 9.32. Okay. And your main is 9.32 and your TPC is 35.29, which is this one. 35.29. Okay. It's up there. Wait a minute. Right. Okay. Now, so this is your TPC 35.29. Then we put here. And your final and your mid port, actual mid port is 9.32. And your starboard mid is 9.32. 9.32. Okay. Then your main will be 9.32 and your final departure is 9.55. Okay. 0.5, which is this one. 9.55. Okay. Then your sinkage is 23 centimeters or 0.23 meters. Okay. Which is this one. Okay. Then, according to the problem, we use the TPC of 35.29. So 35.29 once. Then you press this one and enter. Then you have here 35.29 and your remaining cargo to load is 812, 801, 811.67, which is, okay, this run on top ready to 11.7. Now, the problem stops here. So he's only asking how much remaining cargo to load. Okay, but I'm going to expand this further to distribute this into a cargo hold. So what happens if we load this figure? I'll just say we copy this for the sake of argument or computation. Put here 811.7 according to the figure in the problem. And look here, the final drop departure is 9.55, which is the same here, and the sinkage is the same here. Okay, so the problem stops there, and I proceeded if we're going to distribute it to a hold, a cargo hold. So it says here, then go to trim holds 2. You go to trim holds 2 here. Then you go up. But here we don't load in a vessel with the decimal point. So we have to round it up. So we have put this to 812 for the sake of loading. No, you put here 812. 812. What happens if you load 812? You got your 9.5501 and your sinkage is 2301, which are almost the same here and this one. So we go to trim holds 2. Okay, trim holds 2. Then you have here 812. I have here 812. Our trimming hold is 1 and 4. And we should depart at 11 kill. 11 kill, no trim. So we put here 0, no trim. And what will be our cargo to load in hold number 1 and number 4? So in number 1, you have to load 332. So I put here 332. 332. And number 4 hold will be 480, which is this one. 480. And what will be our departure drop? Our departure drop forward will be 9.55 and up will be 9.55. 0 trim and main drop is 9.55. So this is our target drop. And what will be our deflection is 0. See? See how accurate this problem is. You have a zero deflection. This emphasizes that you will never excess your cargo or shortage of cargo. It is exactly as is when you are looking for the target drop. So you will never you never get less cargo or more cargo. This is what the program is. Okay. Then we go back here, put it here, there, and scroll down and look at if hole number one. You're going to load 332, which is this one, and you have the LCG. And number four, you load 480. And number four here, and yours is LCG, and your departure drop would be the same. You get the target drop here. Okay. Forward is 9.55, up drop is 9.55, you have zero trim, and your main is 9.55, and here your deflection is zero. This is really a very accurate program. You will never get overload or short of cargo. Okay. Then we go to the trim table. I go up and trim table. Okay. Now this is the initial drop of 9.32 forward, up 9.32, main is 9.32, your main is 9.32. This is the initial. Okay. So since we are going remaining cargo is 812, it is already distributed in hold number one, which is 332, and hold number four of 480. In your manual, you have your trimming correction, meaning, for example, in hold number one, you have a forward correction and up correction. So in hold number one, your forward correction is 9.0, and up correction is negative 0.7. So in number four, hold, your forward correction is negative 1.5, and up correction is 5.3. Here it doesn't show which hole are you going to load first. It's either 1 or 7, but it just shows the figure of the correction, and you will get the final drop of, after putting in this forward and up correction and these figures of how much you need sold. And the final drop would be forward would be 9.55, up drop would be 9.55, main drop would be 9.55. Your main is 9.55 and you have a zero trim. And look at your deflection is zero. Also a very accurate program. And there's another way of using the trim table. Okay. And I go up. Then slide a little bit. Okay. And hold number four, since we are going to first load in hold number four to have a trim. So in hold number four, you load 480, and your forward correction is negative 1.5, you get 1.5, and up correction is 5.3, you get 5.3. And in hold number one, cargo is 332, you get 332, your correction is 9, 90, and forward correction is 90, and up correction is negative 0.7, then you have a negative 0.7. Okay, slide it a little bit. Now first, you are going to load in hole number 4 because you will have a good trim up. Okay, so from your initial, after you have loading 480, and this is your forward and up initial drop. Once you're completed loading 480, your initial drop will be 925 forward, and up will be 9.57 up. So you put this down here, carry this one down here. So Now you're going to load in hold number 1 of 332 metric tons. Once you have completed this figure, your final drop forward will be 9.55 and your up drop will be 9.55. So even kill, since your even kill, your zero, you have a zero trim and your main drop is 1.55 and your flexion is zero. Then I have here another program, which is form 7, what I call how to find drop and trim when handling weights involving large changes in mean drop. In here, I use the density, but in other program, trim table, here you don't use any density, and trim two holds, here you don't use any density, and in form 6, you don't use any density here. Okay? There. But in form 7, you will use your density. So assuming that is floating in a salt water, which is 1.025, then you put your initial drop forward of 9.32, then your up will be 9.32. Okay, scroll down, then according to your plan, in hold number 1, you're going to load 324. Okay, hold number 2. Hold number 1 is 332. Oh, excuse me. Is it 332? Okay, 332. Put 332. 332. And number 4 would be 480. 480. 400, 480. And you put in your LCG. LCG. Okay. And here you put your next your LCG density in your final departure of 1.025, and your final drop will be 9.55, which is this one. So your main drop will be 9.55, your forward is 9.55, up drop will be 9.56, and your trim is almost 1 meter. But what matters more is your main drop of 9.55. Okay? If that's clear, then we go to form 6. Let me see, guys. Okay. This is when you're using the TPC of 9.29 of your initial drop. Okay? Excuse me. But in actual practice, guys, take note. In actual practice, I don't use this TPC of this initial draft. What I use the TPC is your final draft or your departure draft. So with your departure draft of 9.55, you take the TPC and interpolate, which is 955, you interpolate the TPC, and the TPC that you should use should be 3546, not this one. So I use, this is my actual practice, guys. So I use this TPC of 9.55 or the departure TPC. I put here equal and enter and 10. This will be TPC. Then you have a new recommended cargo to load for trimming. Did I get this one? This is the formula, guys. K8, which is K and 8, which is the sinkage, multiplied by, this should be, let's say, take this down, put here, times 1. Okay? Okay. Again, K8, which is the sinkage, K and 8, which is 23 centimeters times M3, which is the TPC of 35.6 times 100, and you will get a figure of 815.64. Okay. Look at the formula. Sinkage times TPC times 100. Okay. That is the same here. You see sinkage 8, K8, and M3 times TPC times 100. Then I get a figure of 815.64. Okay. So, scroll down. Then you put this figure. Let's say, let's make it 816. 816. What happens if you load 816? Then, after loading 816, then your mid drop will be 9.55, almost the same here. And your sinkage is 2301, which is almost the same here. Then what it says, go to trim holes 2. Okay, I go to trim holes 2. This one. Here you got 816, and here 816. Then you have trimming hole 1 and 4. And how much are going to load in hole number 1? We have no trim, 0. And what is recommended to load in hole number 1 is 334. Go to 334. Okay. 334. And number 4 should be 482. 482. There you are. And your final departure drop would be, forward will be 9.55. Up drop will be 9.55. Zero trim and mid drop is 9.55. And you have a zero deflection, which is also accurate. Then we go to the trim table. Go up. This is your initial drop. This should be your final drop. Okay. So we go up. You have here the remaining cargo total of 816. And hold number 1. You load 334 and hold number 4, 483. This is the trim correction for each hold. And your final drop would be forward 955, and up drop 955, mid drop 95, mid drop. Then you have 0 trim. So what matters more is your mid drop. Then because your mid drop is 0 and your main drop, mid drop is 955, your pin is 955, your 0 deflection. Okay. Then you go to form 7. This is one. Initial drop 922, and your change the figure in your hold 1 and 4. So the trim table, you go to, trim 2 holds, you go to your, how much you're going to load in number 1 is 334. 334. And number 4 will be 482. 482. 482. I'm sorry. 482. 482. And what will be your, then you put here the density of 1.25 for your final density, and your final drop will be forward 955, and your updraft is 956. Your main drop is 955, and your trim is almost zero. Okay? Or 0 or 1 meter for 0. This is 0. So that's it, guys. So I hope you like this video. Let's put it here. And here we go. Okay. Again, I repeat. Instead, instead of using the TPC here for your initial, if you use this one, show it again. Then you have less cargo. But if I use the TPC for your departure, then you have 4 metric tons more, but your drop, departure drop will be almost the same. See, 555 even king. Okay, so that's it, guys. I hope you like this video, and if you like, please click the like button, share, and subscribe. And please don't forget to click the notification bell. Thank you very much for watching, and have a good day.